Happy learning! Today we're going to do the following application of integrals. A dam is shaped like the parabola y equals x squared minus 100, and our units are feet. The water level is at y equals 0, and the question is, find the hydrostatic force that the dam will need to withstand. Okay, so these questions are pretty tricky, but once you get the integral set up, they're usually not too bad. Okay, so let's first sketch our dam. So it's the graph y equals x squared minus 100. That's a parabola. And the x-intercepts are negative 10 and 10. Okay, pardon the drawing. The water level is at y equals 0, and it goes down to y equals negative 100. All right, so the integral we're going to evaluate is the integral from negative 100, that's the bottom of our dam, to the top of our dam of the weight density of water, which is 62.4, times the depth at a particular value of y, so I'll write depth of y, times the width of our dam at that value of y, which I'll write as width of y. And we're going to integrate with respect to the variable y, but that's no different than integrating with respect to the variable x. Okay, so something to note is that our y value is going to go from negative 100 to 0. So the depth at a particular value of y is just the negative of its value. So at depth, for y equals negative 10, its depth is 10. Okay, so our depth function is negative y. And then the width function, that's the hard one. And the way we get it is, notice, the width is just the x value for a particular value of y. So I'm going to write that as x of y. And it's actually two of it, because we have the right side and the left side. So the width is 2 times this function I'm going to write as x of y. And so what we need to do is solve for x in terms of y. And how do we do that? Well, we know that y equals x squared minus 100. So that tells us that x is equal to the square root of y plus 100. All right, so we're going to evaluate the integral from negative 100 to 0 of 62.4 times negative y times 2 square root of y plus 100. All right, so some of you'd be done with the problem at this point if you are allowed to use integral calculators. I'm going to go through and show how we can evaluate this integral by hand. All right, we could pull out the 62.4 times 2. And I'm also going to do a u substitution. All right, so we're going to let u be the inside of this square root. And so du is just dy. And negative y is going to be 100 minus u. Our new bounds, when we sub in y equals 100, our new lower bound is 0, and our new upper bound is 100. Okay, so our integral becomes 124.8, so we're pulling out the scalar in front, times the integral from 0 to 100 of 100 minus u times the square root of u du. All right, and so this is equal to 124.8 integral from 0 to 100 of 100 u to the 1/2 minus u to the 3/2. Increase the power by 1 and divide by the new power. We have 124.8 times 100 u to the 3 halves over 3 halves minus u to the 5 halves over 5 halves, evaluated at 0 and 100. And when you do that, you get a value of 3.328 times 10 to the 6th, and our units is going to be pounds. Since we started with feet, the imperial units for force is pounds. Okay, I hope you found that useful, and if you did, please leave a like. That really helps out the channel. And leave a comment to let me know what other types of problems you'd like to see. Thanks for watching.